welcome you all to the lecture series of Detailed Electronics KE 039/049. Myself Dr. Kishanu Kundu, and today we are going to discuss more about combination circuits, and today's topics are encoders and decoders. So, these are the list of contents. First of all, we will discuss about encoder, then we will give some examples of encoder circuit. We will discuss about the limitations of encoder, then we will discuss the priority encoder, and lastly we will discuss about decoder. So, let us begin. So, firstly, what is encoder? An encoder is a combination circuit and can be considered as a special case of multiplexer. It has maximum of 2 to the power n number of input lines and n output lines. It does not have select lines like multiplexer. Actually, select lines become the output lines. The size of encoder is 2 to the power n cross n, means if we are having n is equal to 2, then we will be having 2 to the power 2 cross 2, means 4 cross 2 encoder. Clear? Now, what are the examples of encoder? Parity encoders, decimal to BCD encoder, octal to binary encoder, hexadecimal to binary encoder. So, by the name itself you can understand that encoders are basically used for code conversion. In the first unit itself we have discussed different type of codes like binary, octal, hexadecimal. So, the code conversion is done by encoder circuits, different type of encoders. Okay. Next. So, as I have told in the previous slide that if the number of n is equal to 2, then we will be having as 2 to the power 2 cross 2, means 4 cross 2 encoder. You can see in this diagram we are having a 4 cross 2 encoder. So, here 4 input lines y naught, y 1, y 2 and y 3, these are the 4 input lines, and we are having 2 output lines a naught and a 1. So, at any time only one, out of these 4 input lines only one input can be 1. See here at any time we will be having only one, then here one, this and this. So, we can say at any time only one of the these 4 inputs can be 1 in order to get the respective binary code at the output. See, this is nothing but 0, this is 1, this is 2 and 3. So, these are the combination of outputs. So, to get these outputs at any time at one time only one input will be 1. Okay. So, if we write the Boolean function of this truth table, we will getting a1 is equal to, see where a1 is 1 for these two cases, means a1 will be y3 plus y2, and what will be the a naught, you can check a naught will be 1 for this and this. So, this correspond to y3 and y1. So, a naught will be y3 and y1. So, these are the Boolean expression we are getting. So, a1 is y3 plus y2 and a naught is y3 plus y1. So, this is the circuit diagram of 4 cross 2 encoder. Already in the previous slide I have written a1 is nothing but y3 plus y2 and a1 is a naught is y3 plus y1, y3 plus y1. So, we have here a1 is y3 plus y2 and a naught is. So, these are the two OR gates, we are having 2 OR gates to design a 4 cross 2 encoder circuit. Next. Now, already I have told that these encoders are actually nothing but the code converters. Okay. So, for conversion from octal to binary, we are using this octal to binary encoder. So, what is octal? Already these things we have been discussed in number system. Okay. In detailed electronics lecture series, in the number system lecture we have already discussed about octal number system, binary number system. So, octal is base, 0 to 7 octal, okay, and binary here 3. So, here we are having A2, A1 and A0. So, octal is 8 inputs, right. So, Y0 to Y7 total 8 inputs we are having, and for their binary encoder we are having 3 output A0, A1 and A2. Okay. So, we can say that octal to binary encoder has 8 inputs Y0 to Y7 and 3 outputs A0, A1 and A2. Okay. So, octal to binary encoder is nothing but a 8 cross 3 encoder, because here number of n is equal to 3. So, 2 to the power cube into 3 means 8 cross 3 encoder. Okay. So, now we will draw the truth table for octal to binary encoder. So, here you can say, and what is the rule for encoder this type of code conversion? At any time only one of these 8 inputs can be 1 to get the respective binary code. So, here you can say at any time this is Y0 is 0, sorry Y0 is 1, Y1 is 1, Y2 is 1, Y3 is 1, Y4, Y5, Y6 and Y7. Rest other inputs are 0 to get the desired output. See, this is the binary code for 0, this is 1, this is nothing but 2, 3, 4, then 101 is 5, 110 is 6 and 111 is 7. This is nothing but 7. Okay. So, the truth table is done, right. So, in the truth table the specialty is that at any time only one of these 8 inputs can be 1 to get the respective binary code, right. So, now we will write the Boolean expression from this truth table. So, what will be the Boolean expression? See, first of all we will write for A2. See, A2 is 1 for which case? For this one, this, here and here. So, here corresponding to you can say Y4, then this is Y5, this is correspond to Y6 and this corresponds to Y7. So, A2 can be written as Y4 plus Y5 plus Y6 plus Y7. A2 can be written as Y4 plus Y5 plus Y6 plus Y7. Got it? Similarly, A1 we can say A1 is 1 for this. So, this is correspond to Y2. I can write here A1 is Y2, then again A1 is 1 for Y3, again A1 is 1 for Y6 and Y7, Y6 plus Y7, Y6 plus Y7. Okay. Is it clear to you? So, A2 is nothing but Y4 plus Y5 plus Y6 plus Y7 and A1 is nothing but Y2 plus Y3 plus Y6 plus Y7. So, rest what is A0? A0 is nothing but, see here this is 1 means Y1, then again for Y3, then again for Y5 and Y7 plus Y5 plus Y7, right. So, we have written the Boolean expression from the truth table. This is Y5 and Y7. So, Y1, Y3, Y5 and Y7. So, you can check from this, we have written this thing already, we have seen how to write this, the value of A2, A1 and A0. Got it? Now, from this we will draw the circuit diagram. So, this is the circuit diagram. First of all, A2 is nothing but the OR combination of Y4, Y5, Y6 and Y7. You can check like this, this is A2 is nothing but Y4 plus Y5 plus Y6 plus Y7. So, here A2, this is the one OR gate, this is one OR gate and this is one OR gate. clear. So, Y82 is the combination of these 4 lines, then A1 is nothing but Y2, Y3 and Y6 and Y7. You can check it from the previous slide, Y2, Y3, Y6 and Y7, right. So, right like that we have done the circuit diagram. Is it clear? So, this is nothing but the circuit diagram for octal 2 binary encoder, right. Next we will discuss about the limitations of encoder. So, what are the limitation? There is an ambiguity when all inputs are encoder are equal to 0, because it could be one code corresponding to the inputs when only at least one significant input is 1 or when all inputs are 0. So, if more than one input is active means high, then the encoder produces an output which may not be the correct code, For example, if both Y3 and Y6 are 1, then the encoder will produce 111 at the output. This is neither equivalent code corresponding to Y3 when it is 1 or nor the equivalent code corresponding to Y6 when it is 1. So, to overcome this type of difficulties, we should assign priorities to each input of the encoder. Then the output of the encoder will be the binary code corresponding to the high input which has highest priority, and this is nothing but priority encoder, very important priority encoder. So, let us discuss now about priority encoder. So, here already we have seen 4 cross 2 encoder, right. Now, we are going to discuss about 4 cross 2 priority encoder. Let us see what are the features of priority encoder. So, like 4 cross 2 encoder, it is also having 4 inputs Y3, Y2, Y1 and Y0 and 2 outputs A1 and A0, right. You can just go back the slides like this. So, block diagram will be same, right, 4 inputs and 2 outputs. Now, moving further, here Y3, here 4 inputs Y3, Y2, Y1 and Y0. Out of this, Y3 has the highest priority, Y3 is the highest priority and Y0 has the lowest priority. This is highest priority and Y0 is the lowest priority. So, even if more than one input is 1, at the same time the output will be binary code corresponding to the input which is having highest priority. We consider one more output V in order to know, here we have consider one more output V, okay, to know whether the code available at the output is valid or not. Okay. Already we have told that some problem will be there, that the code is valid or not. So, to check the code is valid or not, we have to consider one more output, that is V. Okay. Now, if at least one of the input of the encoder is 1, then the code available at the output is a valid one, right. In this case, the output V will be equal to 1, and second case, if all the inputs of the encoder are 0, here in the first case one input is 1, okay, and in the second case, if all the inputs of the encoder is 0, then the code available at the output is not a valid one, and in this case the output V will be equal to 0. So, if the code is valid, the value will be value of V will be 1, if that is not valid, then it will be 0. So, now let us check the truth table of priority encoder. Already we have done the truth table of normal encoder, 4 cross 2 encoder. Now, we are going to study the truth table for 4 cross 2 priority encoder. Okay. This is priority encoder. Next, say Y3, Y2, Y1, Y0, here Y3 has the highest priority and Y0 is the lowest priority. So, here we can check, see A1, A0. So, if all are 0, this condition. If all the inputs are 0, then the available code at the output is not a valid one. In that case, the output V will be 0. So, this is the first condition, the first case all inputs are 0. So, output value will be 0. Next, then 0 0 0 1. Now, y 0 is 1. So, this is correspond to 0 0, right. Next, and it is a valid one. So, the output of V will be 1. Next, 0 0 up. Now, y 1 is greater priority of having greater priority than y 0. So, if y 1 is 1, then there is no need to check that y 0 is 0 or 1, because it is having lowest priority. So, for that, if y 1 is 1, then we can consider y 0 as cross. Okay, we need not to check, because y 1 is greater priority than y 0. So, in this case the output will be 0 1. Next, for y 2 is 1, y 1 and y 0 are of lower priority. So, these are cannot be, need not to be considered. Okay. In this case the output will be 1 0, and lastly we know y 3 is the highest priority, y 3 is the highest priority. So, if y 3 is 1, then need not to check the rest also. Okay. So, we need to check y 2, y 1 and y 0. So, we will like that all cross, then the output will be 1 1, and V will be 1 for these 4 cases, because all are valid codes. So, the value output of V will be 1. Okay. So, now let us write the Boolean expression for this truth table. See, we are having a K map for A1, A0 and V. So, for A1 we are having y3 and y3, y2, y1 and y0. From this you can see. Okay. So, 4 inputs, and here this is for A1, one will be for A1 and one will be for A0. So, if we solve the K map, so we will get this combination will be equal to y3 and this combination will be y2. Okay. So, we will be getting the value of A1 will be y3 plus y2, A1 will be y3 plus y2. You can check it from the K map. If you have any doubt of K map, you can refer the previous slides of K map. Already we have discussed how we have to write the 4 variable K map, right. Next, for A0 we will having these 3 things y2, y1 and y3. So, we will be having for A0 we will be having y3 plus y2 bar y1. So, these are the expressions for A1 and A0, right. So, like that we have done the, we can check the same, and for V, yes, V all are ones. Okay. So, for that we will be getting one output, V will be for valid, V will be also we will having a expression. So, V will be y3 plus y2 plus y1 plus y0, y1 plus y0. So, these are the 3 expressions, okay, one for V, one for A1 and one for A0. Got it? Next. So, from this we will write the circuit diagram, whatever expression we have got from the previous slide, from this we will do the circuit diagram, right. So, in circuit diagram what is reflecting? The circuit diagram contains two input OR gates, these two input OR gates, then one 4 input OR gate, this is 4 input OR gate, one 4 input OR gate, 2 input NAND gate, 2 input AND gate and one inverter, So, this 4 cross 2 priority encoder is having two input OR gates, one 4 input OR gate, one 2 input AND gate and one inverter. Okay. And what the function of this circuit? This circuit encodes the 4 inputs with 2 bit based on the priority assigned to the each input. Okay. Next. Now, we will discuss about decoder. A decoder we can say the just doing the just opposite work of encoder. So, the decoder is a combination circuit and it can be considered as a special case of demultiplexer, right. It has maximum of n input lines and to the power n output lines. Like encoder, it does not have any select lines, actually select lines have become input lines, right. Size of this decoder, it will be decoder, size of decoder is n cross 2 to the power n. Okay. Encoder was 2 to the power n cross n, here n will be input lines and output will be 2 to the power n, right. The example of decoder are binary to octal decoder, binary to hexadecimal decoder. Okay. These are also used for code conversion. Next. So, similar like what we have done 4 cross 2 encoder, here we are going to discuss 2 cross 4 decoder. So, 2 inputs A1 A0, 4 outputs Y3 Y2 Y1 Y0 and 1 enable pin. Okay. So, if enable is 0, then we need not to consider A1 and A0 and all output will be 0 in this case. Now, if A1 is valid 1, then for 0 0 we will be getting Y0 as 1. If A1 A0 is 0 1, then we will be getting Y1 as 1, where Y1 0 for 1 0 we will be getting Y2 as 1 and for the 1 1 combination we will be getting Y3 as 1, and in all the 4 cases the value of E will be 1, right. This is the valid case. Okay. So, from this we will draw the expression. So, here 2 cross 4 decoder is having, we are having 2 inputs, 4 outputs and we can write the Boolean expression of Y3. So, Y3 will be, you can write Y3 will be E A1 A0, E A1 A0, Y2 will be E A1 A0 bar. You can check it, Y2 A1 is 1 and A0 is 0. So, A1 bar. Next Y1 will be, write down E A1 bar A0 and Y0 is E A1 bar A0 bar. Okay. Got it. So, each output is having one product term, right, and from this product term we can draw the circuit diagram. Already I have written the expressions. So, you can check it from there, and the one example will draw the design of full adder using 3:8 decoder. So, this is nothing but a full adder circuit implementation using 3:8 decoder. So, full adder we are having 3 inputs, we know full adder is having 3 inputs, right. So, for choosing the decoder, first of all we need to check that number of variables. So, here number of variables is 3, right. So, this will be the number of inputs. So, 3 inputs A, B and C in and 2 output. So, we are having S and C out. So, we can check the decoder will be n is equal to 3. So, it will be 3 cross 2 to the power 3, means 3 cross 8 decoder, 3 cross 8 decoder. Okay. And this is the circuit diagram for 3 cross 8 decoder. You can check, we know that sum is nothing but 1, 2, 4 and 7. Already we have discussed full adder circuit in previous lectures, you can check it from there. So, sum is 1, 2, 4, 7 and carry is 3, 5, 6 and 7, 3, 5, 6 and 7. So, this is the circuit diagram for 3:8 decoder and this output is exactly same as full adder. Okay, clear? So, thank you.